Why do we have punch cards? Well, because back in the day, IBM had punched cards that they used, and each one had 80 columns. And so if you had your database of banking information, and you couldn't fit your data onto 80 columns, well, column 81 doubles the cost of your database. And so they're cramming everything into these tiny, tiny fields, right? And that actually goes back even further to the Industrial Revolution. Punch cards were invented for mechanical looms, which were run by these, expert engineers. They wanted to weave these interesting patterns, and they put them on these punched cards. And so I'm bringing this up because this is the story of how humans have gone to technology, right? If you wanted to weave a great rug back in the day, or you wanted to run a bank in the 20s, 30s, 40s, or you wanted to run something on computers at the beginning of the internet, you had to shape yourself. You had to shape your human institution and your knowledge and everything to how that technology worked at the nitty-gritty detail level. Now, there's a parallel track, and this is what was happening in the Enlightenment. There were people like Newton, there were people like Leibniz and Pascal, and they were in academia. They were thinking about, what is the best way I can think about physics? They didn't care if it worked, they didn't care if it made money, they didn't care about any of that kind of stuff, right? And some of them even built like little computers, right? There was this brilliant crank design where you can decide that you want to take an integral, which might let you calculate an artillery trajectory. That was a big thing in the early days of computers. ENIAC, the very first electronic computer, for doing trajectories for artillery in World War II, I guess. So these guys were thinking about, how can I think? And then sort of as an afterthought, they were like, how do I actually, use this for anything? So, they didn't get a lot done. But the reason that I bring these two things up is that we're at a point of convergence. And over the last 2 decades, since the internet started to really take off, we've seen motion from both sides of this spectrum. And if you remember when you used to go on before YouTube, when you went on Yahoo, before it was really a search engine, right? It used to be a directory. You would go on there. You had to know which category your website was going to be in. It was like looking in the yellow pages for websites. And eventually they added a search and this and that. But it was still, you had to know how to use it. You had to use, the exclamation point to do the negative of a query if you wanted to exclude a keyword. And you had to do this and that. It was very much, you learn how the technology works. Then you go to the technology and you get what you want. And on the other end of the spectrum, you had people like Paul Graham, who were trying to do things with a customer-centered interface. And he had a lot of success himself, but a lot of the technologies he used didn't end up panning out for anyone other than him. And so you can kind of trace this. And for me, the very first point of convergence is Google. Because they said, we don't care what it takes to figure out when somebody just types in some random words what it is they actually want. Google doesn't say, learn our query syntax so that you can make a query that'll get you what you want. They say, just type what you're thinking and we're going to figure it out. And they actually managed to bridge that gap completely, right? You can type stuff in and you basically get it. I mean, it works. And this has been happening in more and more parts of the world, right? The blockchain does that for distributed, trust-free computations, right? Now, we still have a lot of room to go, because to buy a Bitcoin, you have to be pretty sophisticated these days, right? And then on the other side of the spectrum, you have the people doing really theoretical stuff, and that's hard to bring over. So I think that we're at a point that started maybe for a few technologies here and there around when Google was born, and it's continuing through today. And the reason that I started my company is that there's an approach in programming that has been used. It came out of academia about 50, 60 years ago. And it was the people saying, I want to just describe the programs that I understand, that I want to make. And this was called functional programming. And they come at it from the theory. And for the longest time, it was barely useful. I mean, it was this academic idea, and it was way too slow. This was one of the competitors to one of the very first programming languages, and it failed. And meanwhile, the people who went to the technology, who learned, okay, if I write this code very specifically, with this kind of timing, it'll work. It'll be what the machine wants. And I started my company, Obsidian Systems, because I saw an opportunity to continue this convergence, where we could take programming technologies that were originally conceived on the basis of what we want to write, rather than on the basis of what the computer needs to have to make it easy for the computer. And they had actually figured out how to automate the process of making it easy for the computer as well. And so you can get good performance, and you can get good results in pretty much every way. So this is a convergence that I noticed. I didn't do this. And the reason that this applies to blockchain is that blockchain requires both in huge measure. When you're working with something at the level of the technology, you're kind of trying to predict what the technology is going to do. You have to understand it perfectly. And if you screw up, you got a big problem, right? And if we look at the DAO and the other things that have happened, I mean, just this morning, I think NiceHash had a massive hack, 16,000 Bitcoin or something like that. And this is because they failed at some engineering challenge. I don't know exactly how they failed, but with the DAO, it was a programming bug that they had in their smart contract. Someone figured out how to exploit it. And then, there goes their money, right? Because now you can move value. If you can figure out the engineering, you can just move value around and cause all kinds of disruptions. So basically, the theory of my company is that we want to take these technologies that give you the ability to write high assurance, proven systems, the kinds of things you might use in aerospace, you might use in banking, that actually provide guarantees about what the system is going to do. And then you want to reduce them to a practical engineering purpose. So we've worked with people who do totally verified smart contracts, right? That's not something that's typically done on Ethereum these days, but people are working on that. And we've also found a way to use these benefits of avoiding bugs and avoiding having to deal with security problems as a way to magnify the productivity of things. So the reason that we started getting into blockchain is that we realized that we have all these people with math backgrounds, with crypto backgrounds, with high assurance software backgrounds, and that's what is needed on blockchain. We need to be able to put things out there that we are extremely confident in, because it allows anyone. The blockchain is a huge enabler, right? It allows anyone in this room to effectively establish something that looks a lot like a bank, right? Not that you guys are going to do that, because we're all making utility tokens, right? But still, you're going to have a whole lot of value flowing through your system, right? How much security do casinos have, right? You don't want to have software that has, the effective security level of a paper bag, right? You got to have real security. You got to have all this stuff thought through. So, basically, my summary here is that I think that we're at a point where we have a huge opportunity, but we also have to start taking the engineering a lot more seriously, because otherwise, you may end up being the next DAO or the next NiceHash or something like that, and you really don't want to be on the receiving end of something that pisses you off and all your clients off, and everybody loses their shirt. So Obsidian does build outs for cryptocurrency apps, cryptocurrency enabled apps. And we do it using the best technology that's come out of academia, that's gone through the rigors of the engineering, the software engineering discipline, and come out the other end as a very strong tool set for producing systems that you can really count on. Thanks.